Hello everyone, welcome to my channel once again. So today we will be solving this problem merge sorted array problem number 88 of LeetCode. Okay, so let us understand what the problem description is. Then we will go with the brute force approach and the optimal approach. Okay, so we are given two integer arrays nums1 and nums2 sorted in non-decreasing order. Non-decreasing order means either increasing or staying same, right? And two integers m and n representing the number of elements in nums1 and nums2 respectively. Then what we need to do is we need to merge nums1 and nums2 into a single array sorted in non-decreasing order, the same, either the increasing or staying same, but it should not decrease. The final sorted array should not be written by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements of that should be merged and last n elements are the set to 0 and should be ignored. Nums2 has a length of n. Okay, so we understand this with the help of a test case, like this is the test case. Okay, see, I'll paste this test case here. What they are saying is there is a nums1 which has the elements 1, 2, 3, 0, 0 and 0, and nums2 which has elements 2, 5, 6. So m equals to 3. So these are the actual elements in the nums1, m equals to 3. And here n equals to 3. It is given in the test case. And these elements, if you see m plus n, the length of the array is m plus n, so that both the arrays can be merged. Okay, so m plus n equals to 3 plus 3 equals to 6. So this extra zeros are there in order to accommodate the elements of this nums2 array as well. Okay, so now the brute force solution will be what? Brute force solution will be what? Copy these three elements 2, 5, 6. Let's see, 1, 2, 3. And these three zeros are there. Instead of these three zeros, copy the elements of nums2 in the nums1 remaining 0 elements 2, 5, 6. Okay, after from the mth place, like third index, because see 0, 1, 2, 3. So mth index to m plus n minus 1 index. So it will be 1, 2, 3, 2, 5, 6. Then sort this array. This is the brute force approach. If we are going to sort this array, this will be 1, 2, 2, 3, 5, 6. So what will be the time complexity of this solution will be? It will be m plus n. What is the size of the array? M plus n. We are using a sorting algorithm m plus n into log of m plus n, because m plus n is the input size. So this time complexity is quite high. So we will not be going with the brute force approach. We will be going with the optimal approach, for whose the time complexity will not be m plus n log m plus 1. It will be much smaller than m plus n log m plus 1 n. Not plus 1, m plus n log m plus n, I'm saying. Okay. So now see 1, 2, 3, 0, 0, 0, then 2, 5, 6. Now what we'll do is 2, 5, 6. We'll have one pointer at m minus 1 and another j pointer at n minus 1 in the two different arrays. Okay. And third as the kth pointer at the m plus n minus 1. We'll check who is greater than I and j, between I and j. 3 and 6. Who is greater than 3 and 6? 6 is greater. So we'll make this 0 as a 6 and move those two pointers. This k pointer will come here and j pointer will move here. Whichever element has been put here, only that pointer will move here. Like 6 element has been put in here, so 6 is moving backward side towards the left. So that will be j minus minus, and this I pointer will remain as it is. Okay. Now see which is the greater between 5 and 3. 5 is greater. So this 0 will be replaced with the 5, and this pointer will move, and this pointer will move. Now see 3 and 2. Which one is greater? 3 and 2, which one is greater? 3 is greater. So we'll have this 3 here and we'll move this pointer here. Okay, and 2 will be here. Okay, now see, now let me write it down. This is k, this is I, and this one is j. Okay, now see which one is greater. So in the else case, what we'll do is we can move any of the pointers, either ith pointer or the jth pointer. So what I will be doing is I will be moving the jth pointer. So j will point to now -1. Okay, and we'll put this 2 here instead of 3. We'll start putting this 2 here. Now there are no element left to be merged. Okay, j is pointing towards -1, and I, all the elements to the left are they are sorted already, so this will manage. So finally, see what the sorted array has become with the help of these 3 pointers. Sorted array has become, see, 1, 2, 2, 3, 5, 6. So this is what the array has become. 1, 2, 2, 3, 5, 6. It has, we have merged two sorted arrays into a single sorted array with the help of these 3 pointers. Now I will be going towards the coding part. Okay. So as per the dry run, we'll have 3 pointers. I equals to m minus 1. Okay. Comma. J equals to n minus 1. Comma. K equals to m plus n minus 1. Okay. Now, while there are two elements, while I greater than equal to 0 and j greater than equals to 0. Okay. So as per the dry run, if whoever is greater, if nums1 of I is greater than nums2 of j, then what we'll do is we'll say nums1, this is not nums, this is nums1. Nums1 of k equals to nums1 of I minus minus. Okay. Else nums1 of k equals to nums2 of j minus minus. Then in every case we have to decrement k by 1, so we are doing k minus minus. Okay. Now the last case remains is if the elements are still present in the nums2 while j is greater than equals to 0. Okay. Nums1 of k equals nums1 of I minus, then what we'll do is nums1 of k minus minus equals to nums2 of j minus minus. Okay, then let me run and see whether it's passing the sample test cases or not. Yeah, it's passing the sample test cases. And now let me submit and check whether it's passing all the test cases or not. Yeah, so this is getting accepted. Okay, now what is the time complexity for this optimal solution? See, the time complexity is what? M plus n. At max, in the worst case, we can traverse from here till the 0 and here till here. So this is big O of m plus n. Or if you want to see more clearly, see here the number of iterations. In this if and else block, only one will execute, right? So let's say we are having this k. So only k minus minus is happening one time here, and k minus minus is happening one time here. So this k is equals to what? This is big O of m plus n. So that's why time complexity is big O of m plus n, and space complexity. Time complexity is big O of m plus n, and space complexity is big O of 1. Because we do not have any other extra arrays, only the input array is used and the output array is already given as an extra space. So whatever the thing which is given as an answer, it corresponds to big O of 1 space complexity. Okay. So now if you are liking my this DSA videos, please do subscribe to my channel. Yeah, so that's it for the problem.